Have you ever stumbled in solving this most important question? If yes, I'm there to elevate your confidence and getting a simple solution. Back to the roots, the topic today is integration using residues. So this is the integration of the type integral minus infinity to plus infinity e power I mx f of x into dx. Now in this video I am going to evaluate integral 0 to infinity cos x by 1 plus x square whole square into dx. So this is the closed contour from the real axis minus r to plus r and along with the semicircle with center 0 and radius r. Let's get started to solve this problem. As you know that e power ix is nothing but cos x plus I sin x. So here equating the real parts. So cos x is nothing but the real part of e power ix. Why I am taking this cos x? As in the question there is cos x, I am talking about this real part. So I am transforming this integral in terms of the real part of, in place of cos x I am writing as the real part of e power ix by 1 plus x square whole square. So talking about this contour, so where C consists of a semicircle CR, that is mod z is equal to 1, which means that mod z minus 0 is equal to 1. So this is the radius and 0 is the center. Through the bounding diameter minus r capital R as shown in the figure. See here, this is minus r capital R. So along with the real axis, and this is a semicircle with center 0 and radius r. So this is the closed contour. So in this closed contour, we have to evaluate the given integral 0 to infinity cos x dx by 1 plus x square whole square. So this is the closed contour with two parts. So integral C f of z dz is split into minus r to plus r along the line minus r to plus r, as this is real axis f of x into dx, plus along this boundary line for the semicircle with center 0 and radius r, that is CR f of z into dz. So in order to calculate this integral, we have to solve these two integrals and we have to add up, so that we will be getting the total integral. Now consider the integral, that is integral C f of z dz is equal to this one, e power iz by 1 plus z square whole square into dz. Clear? Now first of all we have to solve the poles. For solving the poles, as usual, that we have to equate the denominator to 0, as this is the function. So for finding the poles, what we have to do? So we have to equate the denominator to 0. So if I send square to other side, so what remains? That is 1 plus z square is equal to 0. So z square is equal to minus 1. Z is equal to root over minus 1. As you know that minus 1 can be written as I square. So z is equal to plus or minus I. So we got the two poles as z is equal to plus or minus I. So these are the poles of order 2. So z is equal to, this is plus or minus I, are the poles of order 2. So why it is of order 2? So as there is a square here, so we got two poles. So here z is equal to plus or minus I are the poles of order 2. Now we have to check whether these poles are within or on or inside the given contour. See here. So this is the given contour. So this is from minus r to this value is plus r. So this is real axis. So this is y and this is 0. So this is the semicircle with center 0 and radius r. So the contour is along this real axis and the semicircle. So now within this one, so plus I will be, so plus I will be here and minus I will be here. So it is very clear that I is inside the given contour and this is outside the given contour. So within the contour only we have to find the residues and we have to apply in the residue theorem. So here it is very clear that z is equal to I is a pole of order 2, is a pole of, this is order 2. Now we have to find the residue for this. As it is of order 2, there is a formula that, see here, the residue for order 2, the residue of f of z for the pole z is equal to z naught is equal to, this value is, this is limit z tends to z naught. This is 1 by m minus 1 factorial into d by dz power, this is m minus 1 into, this is z minus z naught power m into f of z. Clear? And see, In this, so we have to apply z0 is nothing but the interior pole I, and m is nothing but the order value 2. So if I substitute here, so what will be our residue value? So the residue value will be the residue of f of z. So what is our z0? Z0 is nothing but the interior pole I. So this is equal to limit z tends to z0 value is equal to I, and what is our m value? M is equal to 2. This is 2 minus 1 factorial into d by dz power. M is nothing but 2. So this is 2 minus 1 into this is z minus what is z0? I power m is nothing but 2, and what is our f of z value? So I am showing this f of z value. This is e power iz by 1 plus z square whole square. So this value is nothing but e power iz by this value is z square plus 1 whole square. Clear? And this value is going to become, this is limit z tends to I. 2 minus 1 is nothing but 1. So I'm straight away writing as d by dz. 2 minus 1 is 1. So I have to make a derivative for this. And this is z minus I whole square into e power iz by. So this can be written as this is z plus I and this is z minus I. This value is whole square. Clear? And therefore this is limit z tends to I. This is d by dz times of this is z minus I whole square into e power iz by this is z plus I whole square into this is z minus I whole square. Now if I cancel these two, what remains here? So this will be limit z tends to I. This value is nothing but residue of f of z for the interior pole z is equal to I is equal to this is limit z tends to I. So here after cancelling this one, e power iz by this is e power iz by this is z plus I whole square. Now we have to make a derivative for one time and substitute z is equal to I. So this is of the model, this is u by v rule. So what is u and what is v? So this is u and this is v. As you know that the derivative of u by v is nothing but, so we have to write v square. So this is v u dash minus u v dash. So here it is dash. So derivative. So I am applying the formula here, that is residue of f of z for the interior pole z is equal to I is nothing but, see, this will be v square. So this is z plus I whole square. This value is limit z tends to I. See here, whole square, whole square. So this will be power 4 and this will be z plus I whole square. I am writing v as it is. So this value is v and this value is u. U dash, I have to make a derivative for this. E power iz is nothing but e power iz. For z this is 1, I remains minus. And what is u here? This is e power iz. And see here v dash is nothing but 2 times of this value is z plus I. So this is nothing but limit z tends to I. So this is z plus I is equal to, so this is z plus I into this is e power iz into I minus this is e power iz into 2 after taking this z plus I. So I am taking z plus I common from these two terms. By here this is z plus I power 4. So if I cancel this for one time, so 3 remains. So this will be limit z tends to I. This value is z plus I into e power iz into I minus 2 times of e power iz by this is, see here, this is z plus I whole cube. Clear? Now if I substitute in place of z is equal to I, this will be I plus I into e power. So this will be I square. So this is minus 1 into I minus 2 into e power I square. So this is minus 1. As you know that I square value is equal to minus 1. So I square is equal to minus 1. If I substitute here, this will be again I plus I whole cube. So this is 2I into I. This is E inverse minus 2 times of E inverse and this is 2I whole cube. So this I square value is again minus 1. So if I substitute, this will be minus 2 E inverse. This is minus 2 E inverse. Why? 2 cube value is 8. I square value is minus 1. This is I. So this value is minus 4 E inverse minus 8 into I. So if I cancel these for 2 times, so this will be 1 by E inverse. If I send it to the denominator, this will be 2 EI. Therefore, we got the residue value for the function f of z for the interior pole z is equal to I as 1 by 2 EI. Clear? So, this is our residue value for the interior pole, that is 2 EI. So, after getting the residue value as 2 EI, this is our residue value. So, residue value of f of z for the interior pole z is equal to I is equal to 1 by 2 EI. After getting the residue value, so I have to apply in the residue theorem. So what is a residue theorem? The residue theorem is nothing but so this is our residue theorem. The statement states that this is integral C f of z into dz is nothing but this is 2 pi I into sum of the residues at interior poles. Sum of the residues at the interior poles. So this is going to become integral C f of z into dz value is equal to 2 pi I into what is the interior pole residue, that is 1 by 2 EI. So after considering 2I, what remains? This is integral C f of z into dz value is equal to this value is pi by E. And now what is our C? C is nothing but the closed contour here. So this is the closed contour from minus R to plus R. So this is real axis. So this is Y, and this is a semicircle with center 0 and radius R. The path is along the real axis through the semicircle. So this is the line. So C is nothing but, so we have to split into two parts. So which parts these are? So these are, this is minus R to plus R f of x, as this is real axis f of x dx, and this is a CR. This is f of z into dz value. We got the value as pi by E. So this is equation number 1. Now we have to find out these two integral values and we have to substitute, and therefore as r is tending to infinity, so I am tending r to infinity. If I tend r to infinity, this will become, see here, this is going to become minus infinity to plus infinity f of x into dx plus integral CR f of z dz value is equal to, the value here is pi by E. See here, what is f of x? F of x is nothing but this value is, from our question, this is e power ix by this is x square plus 1 whole square into dx plus this value is a CR into f of z into dz is equal to this value is pi by E. So I am writing this as equation 1, and now I am going to find out the value of integral CR f of z dz. See here, I am giving you a clarity here. So what is our f of z dz? See, it is very clear that integral CR f of z dz value is equal to, this is e power iz by this is z square plus 1 whole square into dz. So I am giving you a substitution as z is equal to r into e power I theta. So if I take modulus, this will be mod r into mod e power I theta. Clearly, this is mod z. So this is r. This value is cos theta plus I sin theta. So mod z value is equal to r into this value is root over cos square theta plus sin square theta, which is equal to 1. So we got mod z value is equal to r. And the next thing here is again the same step substitution here. Z is equal to r into e power I theta. So the derivative here is dz is equal to r into e power I theta. And again, so for theta this is 1, the value here is I. into the value here is d theta. So if I apply modulus, this will be mod r, this will be mod e power I theta, this is mod I, this is d theta. As you know that e power I theta modulus is value is 1, and mod I value can be written as 0 plus I. This value is equal to root over, if I apply modulus, 0 square plus 1 square, which is equal to 1. So these two values are 1. Therefore mod dz value is equal to, this is r into d theta. So after getting these two values here, so this is in place of z as r and in place of dz as r into d theta. Now coming to this, so this value will become, so integral CR, that is e power iz by, this is z square plus 1 whole square into dz. So this is less than or equal to, in place of z I am writing r, that is IR by, this is r square plus 1 whole square into dz can be written as r into d theta. So if I apply modulus, this will be e power IR by, so this is r modulus of r d theta by, this can be written as r square minus 1 whole square. So this value is equal to, if I take r common and here r power 4 common, so here if I take r power 4 common, this is IR d theta by, if I take r power 4 common, this will be 1 by r square whole square. So if I cancel this, 3 times remain. As we tend r to infinity, see here 1 by infinity remains, so which is equal to 0. Therefore integral CR f of z dz value is very clear as 0 as r tends to infinity. So there is no need to write all these, for your clarity I have given. So if you are clear in this particular thing, so definitely you can write straight away as, see this value you can straight away write as 0. So this value is 0. So what remains here? So here the leftover part is this one, that is minus infinity to plus infinity e power ix. E power ix is nothing but cos x plus I sin x by, this is x square plus 1 whole square. And here this is the real part pi by e, and this is the imaginary part I am writing. So this will be minus infinity to plus infinity, this is cos x dx by, this is x square plus 1 whole square, and here I times of, this is minus infinity to plus infinity sin x by, this is x square plus 1 whole square dx is equal to, this is pi by e times of I into 0. So if I equate the real parts to on both sides, so these two are the real parts. So equating the real parts, see here, equating the real parts, then this will be minus infinity to plus infinity. This value is cos x dx by x square plus 1 whole square value is equal to pi by e. I am telling you one thing here. So here if you see, this is origin, this is infinity, and this is minus infinity. The distance from 0 to infinity is same as the distance from 0 to minus infinity. In order to calculate from minus infinity to plus infinity, it is equal to calculate from 0 to infinity for 2 times, as it is an even function. So from minus infinity to plus infinity, I am writing this is 2 times of 0 to infinity. This value is cos x dx by x square plus 1 whole square is equal to, this is pi by e. If I send 2 to other side, so that will be our answer. Therefore this is integral 0 to infinity, this is cos x by x square plus 1 whole square value is equal to pi by 2e. So this is our final answer. This is how we have to solve, and this is also so simple. And let me explain you once again back to the beginning. And this is the question given. So this is the question given. As you know that e power ix is equal to cos x plus I sin x. So in place of cos x I am writing as a real part of this function, and this is the contour. So it is split into 2 equal parts. And see here, so first of all we have to find the poles. For finding the poles, we have to equate the denominator to 0, and after equating denominator to 0, we got 2 poles. We have to check whether they are inside or on or outside the given contour. Here plus I is outside and minus I is outside, and plus I is inside the given contour. So for the interior pole we have to find the residue. So after applying in the formulae, as z is equal to z naught is equal to I and z is equal to m. So here after applying the UV rule here, so we got the residue value as 1 by 2 EI, and after getting the residue value, so we have to apply the residue theorem. So here is the residue theorem, pi by E, and now the total C is split into two parts, and here we have to calculate this one. For the calculation, I have given you a clarity, crystal clear clarity, as there is no need to write here. You can straight away write as r tends to infinity, this integral value is 0. And for your clarity, I have given this one. So how it is going to become 0? So here, after getting 0 value, substituting here, so e power ix can be written as cos x plus I sin x, and this is real part and this is imaginary part. So now I am equating the real part as the question is asked in terms of cos x. Therefore, integral minus infinity to plus infinity cos x dx by x square plus 1 whole square we got as pi by E. As you know that the distance from 0 to infinity and 0 to minus infinity are same. So instead of calculating from minus infinity to plus infinity, I am calculating twice from 0 to infinity, that is 2 times. So this value is 2 times of 0 to infinity. So if I send 2 to other side, this will be pi by 2e is the final answer. Thank you so much for watching. And if you like this video, you know what to do. Please subscribe to your friends, siblings, and whomever you like the most. And I'll be uploading so many videos related to these series. Those are also most important. Watch the playlist and definitely your preparation will be very easy. And subscribe to this channel. Stay connected.